Static electricity. Let's recall. Do you have experience of the instances given below? What is the cause of these effects? 1. A plastic comb or ruler rubbed on dry hair attracts pieces of paper. When a plastic comb or ruler is rubbed on dry hair, electric charge is generated on them due to friction, and this causes pieces of paper to attract towards them. 2. If we pass near a polyester curtain again and again, it gets attracted towards us. Passing near a polyester curtain again and again creates electric charge on it due to friction, and hence it gets attracted towards us. 3. If we rub a blanket with our hands and take it near a metal object, a spark is seen in the dark. Since the blanket is made up of wool, when we rub hand on it, due to friction, electric charge is generated. On the other hand, metal object originally has free electrons in them. These electrons and the charge on blanket interact with each other and a spark is generated. Do you know of other such instances? Discuss them in the class. Electric charge. What do the above observations tell us? These examples are just a glimpse of the electric charge that all objects in our surroundings hold in abundance. Glimpse means a quick look at. Electric charge is stored even in our own bodies. All substances are made of very tiny particles. Electric charge is an intrinsic property of these particles. Intrinsic means internal. Though in this way, electric charge is abundantly present, it is always in a hidden state. This is because two opposite types of charges are present in equal numbers in all these substances. When the positive charge and negative charge on an object are balanced, the object is neutral. That is, there is no net charge on the object. If these charges are not balanced, the object is said to be charged. Try this. How would two charged objects interact with each other? Rub one end of a glass rod against a silk cloth. Due to the rubbing, a small charge will get transferred from one object to the other. As a result, both the objects will become somewhat charged. Suspend this rod freely in air with the help of a thread. Now, charge another glass rod in the same manner and bring it near the suspended rod. What do you see? The two rods push each other away. Now take a plastic rod. Rub one of its ends against a woolen cloth. Bring that end near the suspended glass rod. Now what do you see? The two rods are pulled towards each other. What did you find in the first experiment? Two rods carrying similar charges push each other away. This is called repulsion. We learn from the second experiment that rods carrying opposite types of charges get pulled towards each other. This is called attraction. The scientist Benjamin Franklin named the electric charges positive charge and negative charge. What is the origin of an electric charge? All substances are made up of particles, and these particles are ultimately made up of very tiny atoms. We shall be looking at the details of atomic structure later. At this stage, it is sufficient to know that each atom contains a stationary positive charge and moving negative charges. These two charges being perfectly balanced, an atom is electrically neutral. All objects are made up of atoms, which means that they are electrically neutral. Then, how do objects become electrically charged? For some reason, the balance of electrically neutral atoms gets disturbed. For example, when certain objects are rubbed against each other, the negatively charged particles on one object go to the other object. The object to which they go becomes negatively charged due to an excess of negatively charged particles. Similarly, the object from which the negatively charged particles go away become positively charged due to a deficiency of negatively charged particles. It means that of the two objects being rubbed, one becomes positively charged and the other negatively charged. Try this. Materials: paper, polythene, nylon cloth, cotton cloth, silk cloth, etc. Procedure: first, take the objects mentioned in the chart near some small pieces of paper and observe what happens. Then rub each of these objects in turn against one of the given materials and take it near the pieces of paper. Record your observations in the chart. Material used for rubbing. Object: whether paper pieces get attracted, yes or no. Does the object get charged, yes or no? The objects are 1. Balloon, 2. Ball pen refill, 3. Eraser, 4. Wooden ruler, 5. Steel spoon, 6. Copper strips. Repeat this procedure with each of the given materials. Always remember, each atom is electrically neutral. It has equal amounts of positive and negative charge. If for some reason the negative charge decreases, the atom becomes positively charged. Use your brain power. Do all objects get charged by rubbing? No. Do you know? About 2,500 years ago, a Greek scientist named Thales found that feathers are attracted towards a rod of yellow-colored amber, which had been rubbed against a woolen cloth. Amber is called electron in the Greek language. Therefore, this property of amber to attract things was named electricity by Thomas Brown in 1646 AD. Frictional electricity. The electric charge generated by friction is called frictional electricity. This charge is produced only at the place of friction. Hence, it is called static electricity. It remains on the object for a short duration. The charges of static electricity are absorbed by moist air. That is why these experiments should be performed in dry weather, particularly in winter. Try this. Apparatus: a few straws, woolen cloth, could be socks or gloves, glass bottle. Procedure: place a straw on a bottle. Take another straw near it. Observe what happens. Leave the straw on the bottle as it is. Rub the other straw against a woolen cloth and take it near the straw on the bottle. Observe what happens. Now, take two straws and rub them against woolen cloth at the same time. Keep one of the straws on the bottle and take the other near it. See what happens. keep the rubbed straw on the bottle as it is. Take the woolen cloth on which it was rubbed close to it. Record your observations in each of the above procedures in the chart. Note the procedures: repulsion or attraction, inference. Procedures are: a charged straw is taken near the uncharged straw. Attraction, inference. Electrically charged objects attract uncharged objects. Procedures: two straws carrying similar charges are brought near each other. Repulsion, inference. There is repulsion between like electric charges. And procedures: a charged straw and the oppositely charged cloth, which was used for rubbing, are brought near each other. Or attraction, inference. There is attraction between unlike electric charges. Hence, repulsion is used as a test for identifying an electrically charged object. Observe and discuss. Take thermocol balls in a bottle and shake the bottle vigorously. The thermocol balls try to move away from each other but stick to the bottle. Why does this happen? When thermocol balls are shaken vigorously in a bottle, there is a friction amongst thermocol balls themselves and also between the plastic bottle. The friction between the thermocol balls generates same charge on them, due to which they repel each other. That is, they move away from each other. Whereas opposite charges are generated on thermocol balls and plastic bottle, hence they attract each other. Due to this, the thermocol balls remain attached to the inner wall of plastic bottle. Try this. 1. To charge an object by contact. Rub a plastic comb against paper. Touch this comb with another uncharged comb. Take the other comb near some pieces of paper. What happens? We can see that pieces of paper get attracted towards other comb also. This shows that when a rubber comb is brought near another uncharged comb, the charge gets transferred from that to another uncharged comb. 2. To charge an object by induction. Rub a comb or a balloon on your hair. As shown in the picture, take the comb near a thin trickle of water from a tap. See what happens. Now, draw the comb away from the trickle and observe what happens. Mark your observation with a tick. 1. When the charged comb is brought close to the flowing water, water gets attracted or repelled or remains as it was. Answer: when the charged comb is brought close to the flowing water, water gets attracted. 2. When the charged comb is taken away from the flowing water, it gets attracted or repelled or remains as it was initially. Answer: when the charged comb is taken away from the flowing water, it remains as it was initially. At first, the flow of water is not charged. When a negatively charged comb comes near the flowing water, the negative particles in it nearest the comb are pushed away. That part becomes positively charged due to a deficiency of negative charge. The comb has negative and the water has positive charge. Due to the attraction between these opposite charges, the flowing water is attracted towards the comb. When the comb is taken away, the negative particles in the flowing water come back to their original position and positive and negative charges become equal in number. As a result, the water becomes uncharged again and stops getting attracted to the comb. Always remember: 1. The number of positive and negative charges are equal on an uncharged or neutral object. 2. The electric charge generated by induction stays only as long as the charged object is near to it. Use your brain power. Why does a charged balloon stick to a wall? When a balloon is rubbed against a cloth, it becomes negatively charged. The wall is neutral in nature, but when negatively charged balloon is brought closer to it, it gains positive charge. We know that opposite charges attract each other. Hence, the charged balloon sticks to a wall. Try this. 1. Keep a spent tube light in a dark place. Rub it vigorously with a thin polythene bag. What happened? Why? 2. When an uncharged aluminium ball is brought near a negatively charged balloon, the following things happen. As shown in figure A, an opposite charge is generated in the other object by induction, and both the objects get attracted to each other. As shown in figure B, on touching, both the objects become similarly charged. As seen in figure C, the like charges repel each other. Gold leaf electroscope. This is a simple device to detect the electric charge on an object. It consists of a copper rod which has a metal disc at the upper end and two thin gold leaves at the other. The rod is placed in a bottle so that the disc is above the bottle. When an uncharged object is taken near the disc, the leaves remain closed. When a charged object is taken near the disc, both the leaves are charged by the same electric charge and repel each other. That is, move away from each other or open up. When we touch the disc with a hand, the leaves collapse because the charge in the leaves goes into the earth through our body and the leaves get discharged. Use your brain power. Can we use leaves of some other metal instead of gold in the electroscope? Which properties must that metal have? Yes, we can use leaves of copper instead of gold in the electroscope. Metal used in electroscope should possess the properties like malleability, conductivity, etc. Malleability means can be flattened into sheets. Great scientist. In the year 1752, Benjamin Franklin conducted an experiment of flying a kite with his son William. The kite was made using silk cloth, deodar wood, and a metal wire. The metal wire was joined in such a way that its one end was at the top of the kite and the other end was joined to the string of the kite. There was lightning in the sky on the day they flew the kite. When the metal wire touched the clouds, the electric charge got transferred from the clouds to the kite. When the loose string of the kite became taut and the electric charge reached the earth through the string, a spark was seen where the string touched the earth. Thus, he showed that lightning is a form of electric charge. Atmospheric electric charge. We have experienced clouds, thunder, and lightning. Sometimes we hear or read that lightning struck a tree or a building, and some people or animals were killed. How does this happen? How can we prevent such injury or death? During lightning, heat, light, and sound are generated due to flow of electric charge. This results in fire causing loss of life. In order to avoid this, avoid standing near tall objects like tree or building. Also, lightning conductor should be fixed on a tall building. What is it that actually happens when there is lightning in the sky and when lightning strikes the earth? Let's learn about it. Lightning. When air and clouds rub against each other in the sky, the upper part of some clouds on the upper side become positively charged and the lower sides become negatively charged. The science behind lightning and a lightning strike is complicated. Let us therefore consider a cloud in the sky with a negatively charged base upon a plain ground. When this negative charge on the bottom of the cloud becomes much larger than the charge on the ground, it starts flowing towards the ground in stages. This happens very fast, in much less than a second, and heat, light, and sound energy are produced along with the electric current. A lightning strike. You probably know that when there are electrically charged clouds in the sky, electricity is attracted towards a tall building or tree. When lightning strikes, an opposite electric charge is generated on the roof of a building or on the top of a tree by induction. Due to the attraction between the opposite charges on the cloud and the building, the charge on the cloud flows towards the building. This is called a lightning strike. Use your brain power. 1. What kind of damage is caused by a lightning strike? Lightning strike leads to loss of property and life. 2. What measures will you take to prevent the damage caused by lightning? Lightning is a natural calamity. In order to prevent the damage caused by lightning, following things should be done. 1. Do not stand on open ground or below a tree. Do not go to a high location or climb a tree. 2. Do not stand near an electric pole, a telephone pole, a tower, etc. 3. Do not use plugged-in electrical appliances. Do not use a mobile or telephone. 4. Fix a lightning conductor on any tall building near your house. Do you know? Due to the tremendous heat and light generated by lightning, a chemical reaction occurs between nitrogen and oxygen in the air, and nitrogen oxide gas is formed. It mixes with the rainwater, comes down to the earth, and supplies nitrogen to the soil, thus improving its fertility. 2. Due to the energy of the lightning, the oxygen in the air is converted into ozone. This ozone gas protects us from the harmful ultraviolet rays coming from the sun. Lightning protector. The lightning conductor is a device used for protection from a lightning strike. It consists of a long copper strip with one end forked. This end is at the highest part of the building. The other end of the strip is connected to a plate of cast iron. A pit is dug in the ground, coal and salt are filled into the pit, and the iron plate is placed upright in the pit. There is also a provision for pouring water into it. This helps to spread the electric charge quickly into the ground and prevent damage. Whenever an electrically charged cloud passes over the building, the electric charges flowing towards the building are conducted into the ground through the copper strip, and damage to the building is prevented. When such a lightning conductor earthing is fixed on a tall building, the surrounding area is also protected from lightning. You will get more information about how to get protection from lightning in the lesson on disaster management. Use your brain power. 1. Why is the upper end of the lightning conductor pointed? Lightning rods are pointed, so a charge will be concentrated at the end. If the rod had a round end, the charges would spread equally around its surface. As long as the air is prevented from ionizing, it won't conduct the lightning bolt. The purpose of the rod is to prevent ionization by discharging the ions in the air. 2. Why are coal and salt added to the pit in the ground? In earthing, a mixture of charcoal and salt is used. For earthing, the ground resistance should be minimum in order to allow immense current to disappear rapidly. Since charcoal contains carbon, which is a perfect conductor, it serves the purpose. The mixture has to be watered on a regular basis in order to increase its conductivity.